Hi everyone, welcome to my Max Academy. In this video, we'll continue with the chapter Relations and Functions, which is chapter 1 from your 12th standard CBSE Mathematics. So the next section that we are going to talk about in this chapter is types of function. I'm in page number 7 in your textbook. Page number 7 in your textbook, which is types of function. Types of function. So types of functions. Right? So before we get on to types of functions, we will quickly recap what we had studied in our 11th standard about what is a function, then what is a domain, codomain, range, image, pre-image. So we'll just do a quick recap of what we had studied in 11th standard. So before we move to these types of functions, we will try to understand what is a function or definition of a function, right? So function, definition of a function, which you had studied in your 11th standard. So I will just recap that. So function, the definition of the function is f from A to B, set A to set B, f from set A to set B is said to be a function if for every said to be a function if every element in set A is mapped to an unique, this word is very important, is mapped to an unique element in set B, then we call f as a function, right? F from A to B is said to be a function, if every element in set A is mapped to an unique element in set B. So these two words, every element and unique element, these two are very important. But if you observe our relation, R is a relation from A to B, means R is a subset of A cross B. That is our relation, right? But function is again a subset of a relation. So we call a relation as a function. We call a relation, or a relation becomes a function if it satisfies this condition. If every element in set A is mapped to unique element in set B, then we call the relation f as a function. Function is always a relation. Function is also a subset of A cross B. Function is always a relation, but it becomes a function, right? A relation becomes a function if it satisfies this condition. If every element in set A is mapped to a unique element in set B. So we'll see some examples for a function. So suppose let's take an example. So we can represent our function as different representation that you would have studied in the set form or in an arrow diagram form and all that. So suppose if there is a function, I'm using this arrow diagram representation. This is A set and this is B set, and f is a function from set A to set B, right? Suppose if we have 1, 2, 3 are the elements, and this has suppose 3, 4, 5, 6, right? F is a function from A to B. Now, as per the definition of the function, every element in A should be mapped to unique element, which means only one element in B. So which means I can do the mapping like this: 1 goes to 3, here f is a function, 1 goes to 3, and suppose 2 goes to 5, and 3 is mapped to 6. Now this satisfies the condition that every element in set A, every element is mapped to unique element in B. So it's a function. It's also a relation, but in particular it's a function. So every element is mapped to an element in B, and it goes to only one element. This 1 goes to 3. The 1 again cannot go to 4 also. So this is a function. It's a function. F is a function. F is a function. Suppose if you take like this 1, 2, 3, same set with 3, 4, 5, 6 to another set. So this is your A set, this is your B set. Suppose if I have like this, 1 goes to 3, 2 goes to 4, 3 goes to 5, and 3 goes to 6. Then in this case, this is not a function. This is set A, set B. If we ask whether this is a function, this is not a function because the element 3, every element is mapped. So this condition is satisfied. Every element in A is mapped. Every element is mapped, but it should be mapped to a unique element in B. But 1 goes to only 3, 2 goes to only 4, but 3 goes to 5 and 6. So one element cannot go to many elements here. One element here cannot go to more than one element. It goes to 2 elements. 3 is mapped to 5, 3 is mapped to 6. Then it is not a function because 3 has to be mapped only to an unique element, only one element in B. The 3 cannot be mapped to 2 elements in B. Therefore, this is not a function. This is not a function. But it is a relation. It's not a function. Right? If I say this as F is here, this F from A to B is not a function, but F is a relation. But F is a relation. It is a relation, but it is not a function. See, again, this is the way that we represent using arrow diagrams. The other way to represent this function is we can even write it as a set. Here F will become 1 is mapped to 3, so 1, 3, then 2, 5, then 3, 6. Right? Here it is a function. Here this is not a function. This is not a function, but still F is what? 1, 3, 2, 4, 3, 5, 3, 6. Right? So we represent, but here this F is a relation. It's not a function because one element 3 is going to, it's mapped to 2 elements in B. Therefore, this is not a function, but this is a function. So either you can represent the function in the arrow diagram or like this. Even the relation, I call this as a relation because it is failing this condition, unique element. So this relation can also be represented as an arrow diagram or as a set like this. So here this F is a function, here this F is a not a function, but it is a relation. It is a relation. And everything, both are subset of A cross B. Both are subset of A cross B. Fine. Now let's take one more example. Let's see whether it is a function. So I have a set A, same set B, 1, 2, 3, 3, 4, 5, 6. Now suppose 1 goes to 3, 2 goes to 5. Now the question is it a function? F is a function. F is a relation. Now F is a relation. In general, we'll call F is a relation. Now, is this F a function? Is this relation a function? Which means we should check, is every element in A is mapped to a unique element. Every element is mapped. 1 goes to only 3. Okay. 2 goes to 5. Yes, only 5. 3 does not have a mapping. So this element does not have a mapping in B. Therefore, but it says, the definition says every element in A should be mapped to a unique element in B. So which means every element should be mapped here. But this element does not have a mapping. So therefore it is not a function. Right? So F is not a function, but it is a relation. But it is a relation. But F is not a function, but F is a relation. F is not a function, but it is a relation. Why it is not a function? Because 3 is not mapped. 3 is not mapped to, right? 3 belonging to A is not mapped to any element in B. Therefore, here it is failing. But here, why it is not a function? Because the reason is 3 is mapped to, or 3 belonging to the set A, because 3 is present in both. So this 3 belonging to A, I am not talking about this 3, I am talking about this 3. 3 belonging to A has 3 belonging to A is mapped to 2 elements in B, but it should be mapped to only one element in B. Only one element in set B, but here it is mapped to 2 elements in set B. Therefore, here this relation, in general it's a relation, F is a relation, but it is not a function. Here also F is a relation, not a function, because here F is a relation as well as F is also a function, because it satisfies the condition that every element is mapped to a unique element in, every element in A is mapped to a unique element in B. But there can be some elements here left out which there is no mapping from this set to this set. So here you can have some elements not mapped. Here, right, this 4 is not mapped, or no element is mapped to 4. No element in A is mapped to 4. That is okay. But from here to here you should not leave out anything. Every element should have a mapping. Here I can have a map elements, like this, where no element in A is mapped to 4. That is fine. No element in A is mapped to 4. That is fine. So this is still a function. But every element in A should be mapped to B. So which means we can have extra elements in B. And no element is mapped to that. But every element in A should have a mapping like this. So that is why it is a function. This is not a function. And this is also not a function, because 3 is not mapped. 3 is not mapped. That's the reason why it is not a function. Here the reason why it is not a function is 3 is mapped to 2 elements. So it is not a function, because 3 should go to only one element. Every element should be mapped to unique. This condition is failing. Uniqueness is failing. Unique means only one element. Fine. So now what we will talk about is, all of you now pause the video and take these notes. Then I will do one more thing. I will talk about the domain, range and all that. So I am erasing these which are not functions. Now we will talk about the domain of the functions. A domain of the function is domain of the function. Domain of the function is, if f is a function from A to B, then A is called as, I'll erase this. If f is a function from A to B, right? If f is a function from A to B, then the set A is called as domain of F. Domain of F. And B is called as codomain. Codomain of F. Right here, if you take A set is 1, 2, 3, B set is 3, 4, 5, 6. For this particular example, I am writing the same thing here. Suppose A is a set, B is a set, and 1, 2, 3, it has, suppose 3, 4, 5, 6, and 1 goes to 3, and 2 goes to 5, and suppose 3 is mapped to 6. Then, so what is this is a function f. What is the domain of f? Domain is domain of this function f, and it is a function. The same thing I have written here. It's a function, and because every element in A is mapped to a unique element in B, so it is a function, right? So domain of f is set A. The domain of f is A set, which is 1, 2, 3. So this is your domain. Domain of the function is 1, 2, 3. The set 1, 2, 3, which is A set. And codomain is codomain of F. Codomain is also a set, which is the B set. So B equal to, you have to take all the elements in B. The complete B is the codomain, which is 3, 4, 5 and 6. So always this set is a domain and this set is a codomain for a function. Fine. Okay, now what we have is range of f. Range of f is defined as set of all mapped elements. Range is defined as, I'll write here, range of f is defined as set of all mapped elements in B. So whatever elements is mapped, right? So these are the elements which are mapped. 1 is mapped to 3, 2 is mapped to 4. So these are the elements from B, whichever is mapped. So which means that the range of f is 3, 5 and 6. Right? 3, 5 and 6. 4 will not come here. Right? 4 will not come here. And these 3, 5 and 6 are called as images. Images. Or we call this as 3 is image of 1. How do we read this? 3 is the image of 1. 3 is the image of 1. And here we call 5 is image of 2. And here we call 6 is the image of 3. 6 is image of 3. These 3, 5, 6. Right? Range is set of all mapped elements, or we can say set of all mapped or images. Or we can say set of all mapped elements in B. Also range is also called as set of all images. Set of all images. Set of all images. So which means your range is 3, 5 and 6 because these are images. 3 is the image of 1, 5 is the image of 2, 6 is the image of 3. So range is these elements where you have a mapping. This is not mapped. No element here is mapped to 4. No element in A is mapped to 4, so 4 will not come in the range. So there is a difference between your codomain and range. Codomain is complete B, but range is only the elements which are mapped, or only the images. We call these as images. 3 is an image, 5 is an image, 6 is an image, 4 is not an image. Then no element is mapped to 4. No element is mapped to 4, therefore 4 is not an image. 4 will not be part of range. 4 will not come in the range set. Right? Now we know what is the domain. What is the codomain? Codomain. Domain. Codomain and range of f. Now next what we have is, again we call it as these elements. These are called as pre-images. 1 is the pre-image of 3. 1 is called as, so here I will write 1 is pre-image. Image of 3. 1 is the pre-image of 3, or you can call 3 is the image of 1, or 1 is the pre-image of 3. I can write it here. 1 is pre-image of 3. Again 2 is the pre-image of 5. 2 is pre-image of 5. Like that, 3 is the pre-image of 6. 3 is pre-image of 6. Right? And these images will be in B and pre-images will be in A. Pre-images will be in A. Fine. So all of you pause the video and take the notes. Now we will move on to types of functions. Now we will go to types of function. Now types of functions. Now I am in the definition 5 in your textbook, page number 7, which is definition 5, which is for a one-to-one function. One-to-one function. Right? Or we call this as, it is a notation, or you can say one-to-one function. One-to-one function. right? Or it is also called as, in bracket, it is also called as injective function, one-to-one function, or it is called, the other name is injective function. Now, a function f, this is a definition of one-to-one function, which is called as an injective function, is a function f from x to y, set x to set y. I took it as, here we had it as a to b. It is from x to y, from one set to another set. The set can be a to b or x to y, it doesn't matter. A function from x to y is defined to be one-to-one function, one-to-one or injective, bracket or injective, if the images of distinct elements of x under f, elements of x means set x under f, are distinct. See, or in other words, what it means is, suppose, which means in other words, for every x1 comma x2 belonging to the set x, comma, f of x1 equal to f of x2. This means implies x1 equal to x2. x1 equal to x2. Right? If it is not one-to-one, we call that function as many-to-one. That I'll come to that. Let's try to understand what is one-to-one function. Now, a function f from x to y is defined to be one-to-one or injective if the images of images of distinct elements of x under f are distinct. So what it means is, or in other words, the other way to say this is, for every x1 comma x2 belonging to the x, f of x1 equal to f of x2 means x1 is equal to x2. Now I'll explain this, what it means. Suppose if f is a function from set A to set B, or here we'll take it as x and y, okay, from x to y, say 1, 2, 3, I'm taking this, suppose this is 4, 3, 4, 5, 6. Now suppose 1 goes to 3, 2 goes to 4, 3 goes to 6, 3 goes to 6. Then if you see, we call this function f, which goes from x to y. This function is called as an one-to-one function or injective function. Both mean the same. It's called as a one-to-one function because distinct element of x, if I take any two different elements, 1 and 2, any two elements or any distinct elements, they go to two different elements. 1 is mapped to 3, 2 is mapped to 4. They don't go to the same element. Right? So that is the meaning of this. If the images, so these are images. If the images are distinct elements, if the distinct elements mean these two are two different elements, distinct element in x, distinct element of x, they have distinct images. They should have different images. If I take two different elements from here, it should have two different images. It cannot have the same image. So if any elements that we take, any element we take, any 2 or 3 elements or whatever, any set of distinct elements, if I take, all of them should have distinct images. It cannot have the same image. So then you call that as a one-to-one. Here it is a one-to-one function. Suppose if you take here, let's take an example, or I'll try to explain this part also. Or the other way is, for every x1 comma x2 belonging to x, if f of x1 equal to f of x2, which means if the image is same, and f of x1 equal to f of x2 means here it is 3, then which means your x1 should be equal to x2. Probably I'll explain this with using minute one, then you will be able to understand this part. So this also tells the same thing as this, right? So let's go to the minute one function. What is minute one function? Minute one function means, the definition, a function which is not one to one. A function which is not one to one is called as minute one function. A function which is not one to one or injective, bracket injective, is called as a minute one function. So which means, suppose let's take a function from same set x2 say to y, right? So 1 2 3, and I have 3 4 5 6, and 1 goes to 3, suppose 2 goes to 4, 3 also goes to 4. Now is it a function? It is a function because every element in A is mapped and it goes to only one element. 1 goes to only 3, 2 goes to only 4, 3 goes to only 4. 3 can go to the same 4, but it has to go to only 4 or only one element. 3 again cannot go to 6, and that is not a function. So 2 elements here can be mapped to one element, but one element here cannot be mapped to 2 elements, then that is not a function. That is not a function, but this is a function. 2 elements can go to the same, which means 2 elements can have same image. 2 different elements can have same image. So this is called as many to one because many are going to 1. Many elements are going to 1. This is a many to one function. This is not a one to one function because 2 goes to 4, 3 also goes to 4, which means the 2 distinct elements of x, the image is not distinct. Images are distinct. Image should be distinct for one to one. Here the image is same. Here the image is same, which is 4. For example, the other way to say this is here f of 2 is actually 4. This is another way to represent the function. F of 2 is 4 and f of 3 is also 4. F of 3 is also 4. F of 3 is also 4, which means my f of 2 equal to f of 3 because both are 4, which means my f of x equal to my f of x1 equal to f of x2. F of x1 is like 2, x2 is 3, right? My f of x1 equal to f of x2. Does it mean that x1 equal to x2, which means is 2 equal to 3? No, 2 is not equal to 3. But if 2 equal to 3, then it becomes 1 to 1. But it is not. 2 is not equal to 3. The number 2 is not equal to number 3. Therefore, this function is not one to one function. Therefore, this function is not a one to one function, and it is a many to one function. So that is the meaning of this. Suppose if the image is same, 4 is same, then the pre-image also should be same, but pre-image is different. If one image, these are called, if one image has 2 pre-image, then it is not a one to one function. Right? So that is the meaning of this. If f of x1 equal to f of x2, then then x1 should be equal to x2. These 2 elements also should be same. These 2 elements also should be same. Then it is one to one. Here it is not same because 4 is coming to 2, 4 is coming to 4 image of 2, 4 is the image of 3 also. But 2 and 3 are not equal. Therefore, it is not one to one function. Right? So here if you take f of 3 is 1. So we can say f of 3 is 1. Again we will take same f of 3 is 1. So f of 3 equal to f of 3. That means that 3 equal to 3. So here where x1 is 3, x2 is 3. I am taking same x1. Sorry, f of x1 is 1. F of x2 is also 1. When both are 1, then x1 is equal to x2. Which means my x1 is also 3. Sorry, f of 1 equal to 3. I should have written f of 1 equal to 3. F of 1. See, f of 1 is 3. F of 1. So f of 1 equal to f of 1. F of 1 is what? 3. F of 1 is also 3. Therefore 1 equal to 1. Therefore it is 1 to 1. Therefore it is 1 to 1. Right here, if you take the same thing, if any image, you take 4. F of 2 is 4. F of 3 is also 4. But that doesn't mean that 2 equal to 3. Therefore it is not 1 to 1. Fine. So this function is 1 to 1. This function is many to 1. But both are functions. But if this type is 1 to 1 function, this is a many to 1 function. Many to 1 function. Right. Some more example if you want to see for many to 1 is this one. Suppose we can have like this. Set x, set y. F is a function. If I have 1, 2, 3. Here if I have 3, 4, 5, 6. Say 1 goes to 4. 2 goes to 4. 3 also goes to 4. This is also a function. Again, this is a many to 1 function. Because many elements are going to 1. It is called as many to 1. Right? 1 goes to 4, 2 also goes to 4, 3 is also mapped to 4. All are getting mapped to 4. So this is not a 1 to 1 function, but it is a many to 1 function. It's not a 1 to 1 function because 1 is also going to 4, 2 is also going to 4. If 1 goes to 4, then 2 shouldn't go to 4. 2 should go to something else, and 3 should also go to something else which was not mapped by 1 and 2. If all have a different mapping, if each element have a different mapping, then you call that as a 1 to 1 function. And so this is also a many to 1 function. It's not like only 2 elements should go to 1. Even 3 elements can go to 1 element here, or bunch of 10 elements also can go to 1 element. Right? So it is a many to 1. This is also a many to 1 function. Many to 1 function. Many to 1 function. Fine. Okay, now let's go to the next type of function, which is definition 6. All of you pause the video and take the notes. I'm erasing. The next type of function is onto function. Onto function. It is also called as surjective. Surjective function. Surjective function. The definition is given, which is definition 6 in your textbook. So a function f from x to y, set x to set y, is said to be onto, is said to be onto in bracket surjective if every element of y is the image of some element of x. It's the image of some element of x under f, under the function f, under f, which means under the function f. That is, in other words, that is IE means that is, in other words, for every y, the element y belonging to the set y, there exists an element x in capital X, or there exists an element x belonging to capital X, such that my f of x should be equal to y. My f of x should be equal to y, which means a function f is f from x to y, set x to set y, is said to be onto or subjective if every element of y, set y, capital Y means that denotes the set, small letters denotes the element of the set. If every element of y is the image of some element of x under f, under the function f, then we call that as an onto function or surjective function. That is, in other words, for every element y, small y in capital Y, there is a set. There exists an element, that there should exist at least one element in the set x such that f of that element, f of x, should be equal to y. Which means every element in y should be image of some element in x. Every element in y should be an image of some element in x. For example, let me give one example. Suppose we'll take the same set x, another set y, 1, 2, 3. You have 3, 4, 5, 6. So suppose if 1 goes to 3, 2 goes to 4. Fine. Right. Then 3 goes to 5. And suppose we have 4 also goes to 5. Right? It is not a one-to-one function. It's not a one-to-one function because many are going here. We are not worried about here this one-to-one or many-to-one, but we are worried whether it is onto or not. It's an onto function because every element of y is an image of some element of x. If you see 3 is an image of 1, 4 is an image of 2, 5 is an image of 3, 5 is also an image of 4. It can have two right pre-image. 5 is the image of 3 as well as 5 is the image of 4. So which means every element in y is having a pre-image. These are called as pre-image. Or every element is an image of these elements. Every element is an image of 4 is the image of 2, 3 is the image of 1, 5 is the image. So we don't have anything like this which does not have 6 is not an image of anything. Then this will become not onto function. So if I don't have 6, then this is an onto function because every element is an image of some element of x. Every element should be image of something. Right? Which means all these elements are mapped. All these elements in y are mapped. Right? 3 is mapped, 1 mapped to 3, 2 mapped to 4, 3 mapped to 5. So all are mapped. There is nothing like this. There nothing is mapped to this. There is no such element. Suppose if I put the 6, then it becomes not onto. So if it is like this, then this is an onto function. Onto function. Or it is also called as surjective function. Onto function or surjective function. Right? So now we'll take. So one more thing is we call, in general, we can also say a function as an onto if the codomain of f is equal to range of f. Range of f means what? Set of all. So here if you see what is the codomain of f, it is y. Y equal to 3, 4, 5. That is the codomain of f. Now what is the range of f? Range of f is all the mapped elements 3, 4, 5. Everything is mapped. So it is 3, 4, 5. So this is also 3, 4, 5. This is also, so both the sets are equal. When the codomain of f is equal to the range of f, then you call that function f as onto. This is another condition to check that it is onto. This is the definition of onto. All these three convey the same meaning. This means the same as this. This means it is same as this. Every element in y, there should exist an x such that f of x is equal to y, means for every element 3, there exists an element 1 such that f of 1 equal to 3. So 3, again 4. 4 is an element for every y. Here y is 4, small y is 4. For 4, there exists an x. What is the x? 2. So f of 4 is 2. Sorry, f of 2 is 4. F of 2 is 4. For 4, there is an x in capital X such that f of 2 is gives me that y, which is 4. F of x is equal to y. So similarly, I can take 5. So f of, I can say 3 equal to 5. For this element, we should be able to find at least one element. Here we have two elements, but we should be able to find at least one element. We can have more elements like this. We have two elements here, that is fine. But at least we should have one element. So f of 3 is 5. So for every element in y, you are able to find one x here, such that f of that element x gives you this element y. So therefore, this is an onto function. Now let's go to the definition of a function which is not onto function. So it is called as into function. A function which is not onto is called as into function, which is not onto function. Not onto function or not surjective. Not onto function, which is called as an into function. The into function, I will give an example, which is the definition is a function which is not onto is called as into. A function which is not onto function or surjective function is called as into function. It's called as into function. A function which is not onto is called as an into function. Now I'll give an example. Let's take this. Say 1, 2, 3. We'll take suppose 3, 4, 5 and 6. 1 is mapped to 3, say 2 is mapped to 5 and 3 is mapped to 4. 3 is mapped to 4, but 6, right? 6, no element in x. This is x, this is y. No element is x is mapped to 6. Therefore, it is not an onto function. It is an into function. Into function, or you can call this as it is not onto. Not onto function. Because this condition fits for every element in y. Every element of y is the image of some element in x. So for 3 is the image of 1. 4 is the image of 3. 5 is the image of 2. 6 is the image of nothing. So every element should be image of some element here. Every element in y should be an image of some element in x. But we have an element 6 which is in the set y, but it does not have, it is not an image of any element in x. Therefore, it is not onto. So for example, we can even check this condition. If y, for every y belonging to y, there should exist an x such that f of x is equal to y. So this is what we will be using when we are proving a function is onto in all other problems in the textbook. So if you apply the same meaning, that is for every y 3, there exists an x. For 3, what is the x? 1. For this y, the x is 1. For this y, the x is 1. X is 2. Right? For this, if the y is 5, the x is 2. Okay, if y is 3, x is 1. If y is 4, x is 3. If y is 5, x is 2. If y is 6, then what is x? For this y, there is no x, which is mapped to 6. Therefore, this is not onto function. This is not onto function. Again, if you try to find what is our domain, codomain, domain is this 1, 2, 3. Codomain will not be equal to range. Codomain set is what? It is 3, 4, 5, 6. That is your codomain. 3, 4, 5 and 6. What is your range? Range of f is 3, 4 and 5. 3, 4 and 5. 6 will not come because 6 is not image of anything. The range will have only images. Range will have only images. 6 is not an image of anything. So 6 will not come in the range. So codomain is 3, 4, 5, 6. Range is f. They are not same. They are not same set. Therefore, it is not an onto function, which means it is an into function. INTU, into function. When codomain equal to range, then you call it as onto. So all these, this definition or this, all the three have the same meaning. All the three have the same meaning. So we can define or we can check using any one of that. Either we can use using this definition or this statement or this condition to check whether it is onto or not. Right? A function which is not onto, it is called as an into function. It's called as an into function. Now probably we will see one more thing, which is some examples for one-to-one, many-to-one, onto, into, and all that functions. Fine. So we'll give some examples now. Examples for each type. So all of you please take it. I have erased it, but you can pause the video and you can always take it. I'm erasing this. Now we will have some examples for different types of functions. Examples for different types of functions. Examples for types of functions. Types of functions. What do we have in examples for types of functions? Right. We will see the example that is given in your page number 8. Right. Suppose f is a function from set x to set y. Right. Suppose I write this as capital X and this is set as capital Y. This has element 1, 2, 3 and 4. This has A, B, C, D, E and F. Suppose there is a function f1. F1 is one function. Right? F1 is one function. F1. Suppose F1. We'll say F1. F1. So 1 goes to A. 1 is mapped to A. And 2 goes to B. 2 goes to B. Right? And 3 is mapped to D. And 4 is mapped to C. 4 is mapped to C. Now, if you see these functions which is given in this example, you will find that now what type of function it is. What type of function it is. Just a second. My laptop is running out of battery, so I just plugged in. Okay, sorry. Now what type of function it is? Now every element is mapped to a unique element, so it is a function, right? And again, two distinct element, right? In X they have two distinct images. They don't have the same image, so it's a one-to-one. So one element goes to A, then 2 also doesn't go to A. 2 goes to different element. So two different elements will go to two different images. When two different elements in X goes to two different images, then it is one-to-one function. So it's a one-to-one function. It is an example of one-to-one function. Also, it is not onto, because whether it is an onto function, because a function can be both one-to-one and onto, or one-to-one and into, or many-to-one and onto, or many-to-one and into. All the four combinations are possible. So it's an one-to-one function. Is it an onto function? Now for onto, every element should be image of this. So A is the image of B is the image of 2, C is the image of 4, D is the image of 3, E is not image of anything. Then it is not onto. So every element of Y should be image of some element in X. Then you call that function as an onto function. Here it is not onto because the element E does not have any element such that E is the image of that element in X. F is also not an image of any element in X. Some element should be there in such a way that F should be an image of some element in X. then you call that as an onto, but here it's not onto, so it is into function. Into function. It's not an onto function. When you call this as an into. So this is an example of a function which is one-to-one but into. It is one-to-one and into function. Now let's take second function. F of 2 is again from x to y. Again from set x to set y. Now let's take x as a set and capital Y as another set, which is again 1, 2, 3, 4. Here we have A, B, C, D, E and F. Now the mapping is 1 goes to B, 1 is mapped, 2 is also mapped to B, 3 goes to C, 4 goes to D. Now is it one-to-one function or many-to-one function? It is clearly many-to-one function. It's not one-to, because many elements are going to the same image. If two different elements have same image, then it is not one-to-one. If two different images have different images, any two elements that you take, any 2 or 3 elements you take, they should have different. If I take 2 elements, it should have 2 different images. But here these 2 elements have the same image, which is B. 2 elements in X, they have the same image B. Then it is not one-to-one. So it is not one-to-one. So it is many-to-one. Many-to-one. It's a many-to-one function. Right? So it is not one-to-one. Now we should check whether it is onto or into function. Is it an onto? Which means if you see any element that is not image of anything here, A is not the image of anything. Therefore immediately we can say it is not onto. Therefore it is an into function. It is an into function. Because A is not image of any element. Every element here should be image of some element here. Then you call that as an onto. Every element in Y, we should be able to find one X such that X is mapped to Y. That X is mapped to the element Y. But here if I take A, element A from the set Y, A does not have any element in X such that A is the image of that. Similarly, we have E, we have F also. But even if one element, if it fails, it is not onto, which means for every element we should be able to find an element in the set X such that f of X, f of that element should be Y. So it is not an onto function, but it's an into function. So this is an example of a function which is many-to-one and into, which means neither one-to-one nor onto. Right? The third one, f of 3, third function, it again from X to Y. Third function from X to Y, which is in this form. Suppose I'm writing again here, this is capital X set, this is capital Y set, 1, 2, 3 and 4. This is A, B and C. Now 1 goes to A, 2 also goes to A, 3 goes to B, 4 is mapped to C. 4 is mapped to C. This is your function F3 function. Now the question is this function one-to-one? To check it is one-to-one, we should take any two elements and make sure that they have 2 different images. But these 2 elements are 2 different images, but they have the same image. If 2 elements in X is mapped to 1 element in Y, then it is not a one-to-one. It is a function, but it is not a one-to-one function. It is not a one-to-one function. It is many-to-one function because many elements are going to one element. That's why it's called many goes to one. That's why it's called as many-to-one. So 2 different images are having the same image. When 2 different elements in the set X, which is the domain of the function, if they have the same image, then it is not a one-to-one function. So this is many-to-one function. Many-to-one function. And now we have to check. Now we have checked between one-to-one and many-to-one. It has become many-to-one. Here it will go 3 goes to only B, 4 goes to only C. But that doesn't mean that it is one-to-one. It should be true for any element that we take. Right? So every element. So no 2 element can have the same image. Then it is one-to-one. But here if you see 2 elements, they have the same image. So it is, even if it fails for one pair, it is not one-to-one. So here it is many-to-one. Now is it onto? Onto means every element in y should be an image of some element in x. A is the image of 1. A also has, A is the image of 2 also. Also B is the image of 3. C is also image of 4. So every element in y is the image of x. Image of some element in x. Every element in the set y is the image of some element in x. So therefore it is onto. It's an onto function. Or it is also called as surjective. Onto is also called as surjective function. So this is an example of a function which is many to one but onto function. Many to one and onto. Now the fourth function f of 4, f4 function, which is from x to y. So again we have the same set x, we have the same set y. Fine. So how is that? Yes. We have 1, 2, 3, 4 and we have A, B, C and D. We have A, B, C and D. We have A, B, C and D. Now the mapping is 1 goes to A. Oh, sorry, 1 goes to B. Doesn't matter. Still, so 1 goes to B. Then 2 goes to C. 2 is mapped to C. And 3 is mapped to A. 3 is mapped to A. 4 is mapped to D. Now, this is it a one-to-one function? Yes, it is a one-to-one function because if I take two different elements, 1 and 2, they go to two different images. Any two elements. If I take 2 and 3, they go to, so 2 goes to C, 3 goes to A. So they go to two, so two different elements have two, so two distinct, the images of two distinct elements in X are distinct, which means two different elements have two different images. 2 and 3 have A and C. 2 has C as the image, 3 has A as its image. So similarly 4 goes to D. So no two element goes to the same element here. So two different elements are going to two different elements have two different images. When two different elements in X have two different images in Y, then it is one-to-one. So it is a one-to-one function. It is also called as injective. It is also called as injective function. Injective function. Injective function. So this is, here also I can say injective. It's another name for one-to-one. It's an injective function. Now is it onto function, which means it will become onto if every element in Y is an image of some element in X. Every element A is the image of 3, B is the image of 1, C is the image of 2, D is the image of 4. So every element in set Y is image of some element in set X. Therefore it is onto. So therefore it is onto function. It is an onto function which is also called as surjective. Surjective function. Surjective function. Clear? So these are four types of functions possible. Here it is one-to-one and into function. Here it is many-to-one and into function. Here it is many-to-one and onto function. It is here one-to-one and onto function. Next we have one more type, which is the definition 7 in your textbook, page number 8. So definition 7 is definition 7, which is for bijective function. Bijective function. Definition of a bijective function. A function f is said to be a bijective function. A function f from set x to set y is said to be bijective. Is said to be bijective. Bijective if f is both, the function f is both one-to-one and onto. One-to-one and onto. A function f from x to y is said to be bijective if f is both one-to-one and onto. Any function which is both one-to-one and onto function, that is called as a bijective function. If we say f is bijective, it means f is both one-to-one and onto. So this is an example of a bijective function because it is both one-to-one and onto. So this is also called as a bijective function because f is both one-to-one and onto means it is also called as bijective. It is both injective and surjective. Injective and surjective. Injective means one-to-one, surjective means onto. A function which is both injective and surjective. That's why it's called as bijective. Bi means two. So bijective. Bijective means it is both injective and surjective. Injective means one-to-one. Surjective means onto. A function which is both one-to-one and onto. It is a function which is one-to-one and onto. It is called as a bijective function, and this is an example of a bijective functions where this function is both one-to-one and onto. So we call this as a bijective function. So whenever they say f is a bijective function, it means f is both one-to-one and onto. If f is one-to-one and onto, we call that as a bijective function. Fine. So I will stop the session here. You can pause the video and take the notes, and I will see you in the next video. Please watch my next video for the continuation of this. Thank you for watching. See you in the next video.